In this segment, I'd like to talk about software development challenges for hardware companies. How would you know whether this topic applies to you? Well, do any of these scenarios sound familiar? Does your company have a historical mindset of we're a hardware company, which has not kept pace with your company's current market? Or maybe this sounds familiar, a feeling that software is unpredictable and out of control, and a company feeling that really software being out of control is the tail wagging the dog because hardware really should be the thing that is wagging the dog. Or maybe this, a company culture in which hardware is king and where software development takes a back seat, even though most of the development budget is now software rather than hardware, or most of the staff is now software staff rather than hardware staff. Or perhaps this, you have few, if any, senior leaders with background in software, despite the fact that software now makes up a critical aspect of your organization's businesses. Well, these would be some clues that this talk might apply to you. The title of the talk really is about hardware challenges or software challenges for hardware companies. Do these issues apply only to hardware companies? Well, no, I think this basic set of issues can apply to any company that historically has not had software as its core business, but is making a transition to having software become increasingly important for its business. What we see is that the dynamics in these other kinds of companies are very similar, but the examples in this talk are definitely going to be focused on hardware specifically and the software challenges in those hardware companies. Well, if this sounds familiar to you, then let's get into the talk. The kinds of challenges that I'd like to focus on in this talk are the history of the hardware-software transition, market issues that come up, product development issues that come up, misunderstanding of where the money goes in software. Why does software development cost as much as it does? General management issues, and then wrap up with a brief discussion of some cultural issues that come up for companies as they try to make this transition into being more software focused. Let's take a look first at the history of the hardware-software transition. This may almost go without saying, but really initially what we see is companies that are initially focused just on hardware, no real concept of software at all. Think about, say, telephones in the 1950s. No real software in the phone itself, just a pure hardware device. As time goes by, what we find is that suddenly there's some software that's part of what was traditionally only hardware. And this might be something like, say, cell phones in the 1990s, where clearly there's a little bit of software in there, but we still are looking at the device as primarily a hardware device. As time goes by, though, what we see is that software becomes an increasingly significant part of this thing that historically we view as a hardware device, to the degree that now software really is a major part of the capabilities of that device. And here, of course, we could think of, say, smartphones today, where, sure, there's an awful lot of powerful hardware in the smartphone, but there's also an awful lot of complex software in the phone, and we really have to have both to get the experience that we're so used to. What we've seen over the years is that companies in different industry segments tend to make the transition from being mostly focused on hardware to having a higher focus on software, really as a cluster or cohort of companies, and they go through these transitions more or less at the same time. If we look at the history over the years, we see that in the 1960s and 70s, we had aerospace and defense companies beginning to go through those transitions. We had traditional telecom, landlines going through that kind of transition, not so much in the handset that people would use, but in the back end of those phone companies. When we got into the 1980s, we saw computer manufacturers moving in those directions, where they were becoming more and more reliant on software. And that doesn't just include what we think of as computers per se. It includes things like chips and chip development, disk drives, video cards, and so on. By the time we got into the 1990s, we started to see a broadening of this transition with scientific instrument companies, medical device companies, printing companies making the transition. And then over the last 15 years or so, we've seen this happen in a big way with cell phone manufacturers, auto companies, oil and gas, utilities, publishing, and other kinds of companies. So what we see as industries make this transition is that not every company within industry makes the transition at the same time. There will always be leading companies and lagging companies. In some cases, the lagging companies lag by quite a bit. And we also see that not every company makes the transition completely. When it does make the transition, it may realize that it needs to focus more on software, but may not completely internalize that idea or put all of the changes in place needed to be really successful with software development. We also see that lots of residual issues can remain after the primary part of the transition occurs. So even if a company has mostly transitioned to a greater capacity to develop software, there may still be some issues where they have some problems. And then finally, we see just the general pattern here, which has been going on for decades now, is that lots of companies are relearning the lessons that other companies learned long ago. And the result of that is that it makes it possible for somebody like me to give a talk like this where I can describe some of the patterns we see as companies try to go through this transition. So the challenges that we see for hardware companies as they increase focus on software really come up in multiple areas. And the first one I'd like to talk about is market issues. And generally what we see here is almost restating the prior point, but really is just to say that hardware used to be the key differentiator in the marketplace, and as time goes by, software becomes the key differentiator in the marketplace. And the way this typically works is that one company makes a foray into software, they start to differentiate using software, and then that creates market conditions where other companies, to be competitive, have to make the same kind of transition. And what we typically see then is that software development capability in these companies lags the hardware development capability. And what goes along with that is that as companies see other companies getting better and putting more capability into the software part of their products, they fear that the competition is better at software than we are. And in some cases that's true, and in some cases it's not so true. We certainly have seen cases over the years where companies are, I think, overly fearful of their competitors' expertise or capability in software, and really at the same time those competitive companies are simultaneously afraid of that company being superior in software. And I think this is why industry segments tend to move in unison, or at least in loose lockstep, into focus on software as time goes by. Probably the biggest category of issues that we see is product development issues. And we see lots of issues that come up as a result, in particular, of unvalidated assumptions about software development being the same as hardware development. Now, if you're coming at this from a software background, you probably don't have that issue. But if you are coming at this from the point of view of having been in a hardware company for a long time with a focus on hardware, then it can be fairly difficult to understand, well, how is software really different? And this can manifest in quite a few different ways. One of the main ways it manifests is through the use of the company's stage gate process, which many, especially larger companies have, or just some kind of product commercialization process. And in traditional hardware companies, these processes typically originated on the hardware side of the organization. And what we find as the organizations move to increasing reliance on software is that a lot of times these stage gate processes are not adequately adopted for software. One of the particular ways in which the stage gate is not adequately adopted for software is typically we find organizations underscope the work required to get to the funding milestone or the funding gate on the software side. And so they take percentages of effort that would make sense on the hardware side of the organization, and they assume that that same percentage of effort is enough to bring clarity and certainty and understanding to the software effort, and it really just isn't. We typically see a larger percentage of the effort needed on the software side to get to the same level of confidence that would be needed to get to that level of confidence on the hardware side. We often see misalignment of hardware and software gates. That is, there might be some intuitive correspondence between the gates, but when you really look at it, you find that this software gate doesn't really support that hardware gate, and vice versa. Because of the fact that the gate definitions are not as crisp or applicable to software as they should be, what we see as a secondary effect is that we see the software teams going through the motions of software gate reviews when the work has not actually been completed satisfactorily. And I think this is really a structural systems issue. Because of the way the gates are set up and the way that they aren't adapted as well to software as they should be, it isn't possible for the software teams to go through the gates properly. And so we see this pattern of declaring the milestones to be complete rather than actually doing the substantive work that would truly complete them. And then that creates all kinds of problems for projects as they get underway. Another common stage gate issue we see is allowing too many changes in hardware after the feature freeze hardware gate, and then assuming that software can take up all the slack. Well, in many cases, software can take up all the slack, but the assumptions about how much work is going to be required for software to do that are very naive and optimistic, and so we find product schedules get elongated and unpredictable because of basically unvalidated assumptions about how much of that slack software can take up. Another common dynamic we see in combined hardware-software organizations is that necessary hardware prototypes, breadboards, and so on are not available at the right times they're needed to support software development. And so we see cases like software teams assuming that a button is going to be in a certain location on a device, writing graphical code that tells the user, here, press this button here, and pointing to a part of the screen where the button is supposed to be over to the side. And then when the hardware device actually ships, the button has been moved. And so you have the software that now is pointing to a nonsensical location. And that is symptomatic of poor coordination between hardware and software development efforts, and often is symptomatic of late changes in hardware where the software actually could not react in a timely enough way. And I think a lot of this dynamic can be summarized by saying there's just a misunderstanding of how soft software actually is. Software truly is soft compared to hardware, but that doesn't mean that it's infinitely malleable or that malleability doesn't come with some cost and with some time requirement. And so I think traditional hardware companies often underestimate how much time it takes to actually exercise that softness in software, and that ends up undermining the product development effort overall. And that really is kind of the bottom line here, is that what we find is that in traditional hardware companies, we see overall product schedules dictated by the hardware schedule, even at the expense of the software that is providing a competitive advantage, and ultimately at the expense of product desirability. So what we have is leftover expectations about product desirability coming primarily or exclusively from the hardware, really with software in some cases being viewed as a necessary evil, and not really updating those expectations to fully realize the idea that the software is now just as important a part of the product as the hardware is, and then readjusting product development approaches accordingly. Another issue we see in traditional hardware companies as they become more reliant on software is just misunderstanding where the money goes in software. We published this article in IEEE Software when I was editor-in-chief, which was a comment from a traditional engineering firm. And I thought this was a fascinating comment. It's not an exact quote, but it was approximately the leader of this organization said, when we bid a project where labor makes up more than 50% of the cost, we automatically consider that to be a high-risk project. And I thought that was a fascinating comment because that was from a traditional engineering firm where they do have substantial hardware side or physical materials side of their projects. But what they're saying is that when more than 50% of the cost is labor, it's a high-risk project. And that basically describes every software project, because on every software project, the cost is almost all labor. It's not just more than 50%, it's closer to 100%. And so interestingly enough, that highly effective engineering firm, by implication, would declare every software project to be a high-risk project. And I think that's a very interesting way to view software. Where does the money go in a typical software project? Well, on most software projects, low quality is the single largest cost driver, and 50 to 80% of the typical project's expense goes into unplanned rework. And if we look at this graphically, what we see on a typical project, which you'll see is also labeled pathological project, meaning a project that's not run very effectively, is we see relatively little investment in the activities of requirements, architecture, and detailed design. And then we see a large amount of expense in construction and in testing and debugging. Now, if we compare that activity by activity to an advanced project, we would see that in requirements, we still don't have a vast investment, but we do have literally about twice as much of an investment in requirements on a well-run, healthy project as on the typical pathological project. And I think it's important to point out that that's not twice as much of ineffective effort that many companies are engaged in now. It often needs to be a different kind of effort, ending up in twice as much effort, but twice as much of effective effort. Same basic story in architecture. We see an increase in focus on architecture, not necessarily the same kind of effort that goes in the pathological project, but a greater emphasis. As we get into detailed design, we see, again, a significantly higher amount of effort and thought put into the design activity. And then when we get into construction, though, this is where things get interesting. When we get into construction now, in a pathological, typical project, we start to see a big spike in effort, whereas in a more advanced, healthy project, yes, we see the bulk of the effort in software goes into construction, but in terms of the ratio, it's much less dramatic ratio to detailed design, architecture, and requirements than you would see in a typical project. And then when we get out to testing and debugging, which makes up something like 50 to 80% of the effort on a typical project, on the more advanced, healthy project, we see that's actually a minor activity because the quality is built in the first place, and we're not spending anywhere near as high a percentage of our time in reactive defect correction work as we do in a more kind of average project. Why is this allowed to occur? Well, I think it's allowed to occur in part because the waste in software is just not as tangible or visible as it is in traditional hardware development because it's all labor. If we were going about a physical construction project in a way that was causing lots of errors and rework, we would be having a big pile of materials of waste pile up somewhere, and we have to see it. We'd have to pay to cart it away or recycle it. But in software, all that waste is labor. It's essentially invisible, and so it really doesn't show up unless we instrument our software practices in such a way that we can make it visible, and not that many companies actually do that. Really, I think the key thing to understand here, which has really been known, at least to some people in the field for a long time, was first observed in a study at IBM in the 1970s. And what that study found at IBM was that projects that focused primarily on schedule tended to overrun their schedule goals and were delivered with low quality, whereas projects that focused primarily on quality tended to meet their schedule goals and were delivered with good quality. And so what we find is that the role of quality in software economics is not completely intuitive. How we actually reduce cost of software, a lot of times we find people thinking there's a trade-off between quality and cost, but for the vast majority of organizations, there's no such trade-off. The largest cost driver is already low quality, and so focusing on quality turns out to be really the key to unlocking productivity, to unlocking short schedules, as well as to doing a good job on quality. Another category of issues we see in the hardware-software transition is general management issues. A couple of big ones here. One is that we see that budgeting processes tend to undermine effective software development practices, and this is really about the same issue as the idea that in the stage gate process, the amount of work required to get to the funding gate in software is often underestimated for hardware companies, and that then in turn undermines the budgeting process and leads to all kinds of downstream consequences related to teams being understaffed and projects going longer than they were planned, and so on and so on. We also see another category of issues in the general management area, which is that long-standing general business practices are often more hardware-oriented than software-oriented, and they don't get updated to support the software part of the organization. And this can be really nuts and bolts business practices, like how the company acquires tools or materials or computers, how they support IT operations, how they do master services agreements with vendors, really very kind of nuts and bolts business practices that can undermine the efficacy of the software part of the organization. The final category of issue I'd like to touch on is cultural issues, and here I think this can actually be the toughest nut to crack. The product development issues are probably the biggest category of issues, but some of these cultural issues are maybe the most subtle and in some ways the most difficult. It really starts at the top. We sometimes see lack of full executive support for software, and it's not necessarily even intentional. It can just be in the biases and assumptions and expectations about how hardware is king and software is secondary, and offhand comments about, why is the software part of the organization causing us so many problems and things like that. Part of what exacerbates this problem is that we often see that we have little or no representation of software staff in the upper levels of the career ladder in technical leadership positions. So it's often the case that in hardware organizations, electrical engineers or mechanical engineers or chemical engineers will be able to go very high up in a technical ladder, but the ladder doesn't even have positions for software people to go up as high. So we have this structural barrier to treating software as even potentially equal in the organization. And the corollary to this is sometimes we see there's no clear career path for software staff at all. It's not just the case that it doesn't go as high up the technical ladder, it's that there is no technical ladder for software staff, which is an even bigger problem. A technical ladder aside, we often see that software staff don't get promoted into management positions, or especially into upper management or leadership positions. And if we don't have software representation in the upper levels of the organization, it's really hard to make that transition to treating software as being on an equal footing with hardware. Well, that's really the set of issues that we've seen in a nutshell as companies try to become better at software coming out of a traditional hardware background. You'll notice that I really haven't spent much time talking about technical issues in this talk. And the reason for that is that, number one, we typically see the ability to do good technical work is blocked by these other softer management and cultural issues that I've touched on in this talk. We do find that as companies really need to get better at the technical side of the work, there are well-defined approaches to these technical issues in integrated work between hardware and software. And there's a very well-developed field called systems engineering that many companies don't know about, even though they are in fact doing systems engineering. A great resource in this area is INCOSE, the International Council on Systems Engineering. They sponsor conferences and a number of documents, and so there actually are some pretty well-defined guidelines on the technical side of this equation that I encourage you to check out if you aren't already aware of those resources. Well, what can we say? I think in conclusion, I like this comment from Fred Brooks in the Mythical Man Month made 40 years ago, and he said, paraphrased closely, that managing software projects is much more like managing general projects than many software personnel would like to believe, and it is much more unique than many general managers would like to believe. And this is really the challenge that we face with the hardware to software transition, is what parts of the software development are really like what we're familiar with in hardware, and what parts are different. Some of those differences are intuitive. Some of those intuitive comparisons don't work out as well as we would like them to. And overall, I think there's a lot to be learned from experience in this area. As I said at the beginning of this segment, lots of companies have been making this transition for 20 or 30 years, and so fortunately we do know some of the lessons learned, and that's something my company has helped organizations with now for many years.